In the previous chapter, we have seen the principle strain and stress, and in this chapter, we are going to see the basic fundamental of the upcoming chapters, which is namely simple bending, then bending moment diagram, shear force diagram, and also it is regarding to your deflection inside your beam. So, how this chapter is going to relate relevant to this kind of subject, because these topics, because uh, if you're going to solve this kind of equation, you need to draw a free body diagram for a different beam kind of structure, and there are many supports, and you have to draw a free body diagram with respect to their forces, and you have to find out the forces, and after that you have to move with the shear force diagram, and after that bending moment diagram. So basically, you have to move with respect to that, and so moving such kind of problem, you must need to go first with your basics. If you are thorough with your basics, so there will be no problem, because if you make a mistake at the starting of your problem, so entire problem and entire your work is going to be waste. So we are going to start with the firstly type of support, and after that we will go to the type of beam, and it has a small concept in it, and I will going to explain whenever that point come in my mind. I'll going to share with you. So this is the first support. Support is divided into two kind of support. First is simply supported, and second is the fixed support. And in simply supported also categorized into two subcategories. One is the roller support, and another is some hinge support. And most of you people are familiar, because if you are studying about the gate, you have seen this thing in your entire engineering section. So in the roller support, only thing is need to concentrate is that whenever you're going to apply any support to any link, so what it will does, basically it will reduce the degree of freedom of that link. So if you put any link in the atmosphere, it has a 3 degree of freedom. So if you apply any support to it, it will definitely it going to reduce its degree of freedom. So in this condition, the first support we are taking as a roller support. So the roller support is nothing but a support which is allow that link to move in the horizontal direction. Just simply take an example for this mobile. If it is, I have applied the roller support in this section, and this is the free section. So it is it is allowed to move in this direction, which is nothing but it can allow to rotate, and it can allow to move in the horizontal direction, but the only restriction in the vertical direction, so it is not allowed to move in the vertical direction. So the concept behind of the forces is nothing but which is acting in that direction, which direction we are going to reduce the degree of freedom. So in this condition, the degree of freedom is going to be reduced in the vertical direction. That's why we are applying the support in the perpendicular to that direction, which is perpendicular to that surface. And their notation we are going to see in the different charts. So for in there you will get a clear picture how this roller supporters look like, and how you need to identify, and how it looks. So secondly, we move the hinge support. So in hinge support, basically they used to reduce the two kind of the movement. Hinge is nothing but one kind of pin kind of support, and most of time you can see more, and it has a huge application rather than the roller support. Roller support you can see in the ball joint, and the same kind of support is number of available application is available. If you see any railway station or any linkage, there are a lot of example is available. So in this condition only, it avoid to it is allowed to move in the rotational direction, because if you apply the hinge point in this direction, so what it will do, it will not allow to move in the vertical direction as well as horizontal direction. Only it is allowed to move in the rotational direction. So uh, the force only going to generate, which is the restriction moment is the horizontal direction and vertical direction. That's why in in hinge support, the generation of we are used to give two support in the vertical direction and horizontal direction. So vertical direction must be in upward direction or in downward direction based on the application. Also it is acting from left to right or right to left. It based on your forces. Anyway, it doesn't matter, because if you give any direction to it, at the end you get to know if it is we are going to give a that sign for upward force is positive and outward is negative. If it is come upward, then it must be positive. But if you take positive and the force come as a negative value, then you have to assume that the force you have assumed in the wrong direction. You have to recorrect that in the next way. So this is we have finished with the simple support. Now we will move to the fixed support. Fixed support, there is a little confusion in this kind of support, because sometimes they used to call it as bolt-in support, which is and another support is the clamp support. So these are two basic kind of the support you used to call as the fixed support. And once you and this kind of support you can see everywhere, where a bolt the permanent welding kind of joint is it's an example of the clamp and bolt kind of support, because it is not allowed to move. And this kind of support restrict all kind of movement. It will not allow to move any direction. So first, it is restrict in the vertical direction movement and horizontal direction movement, and the last movement we have is a rotational movement. So in this condition, all three kind of the movement, it is getting locked. So just because of that, in the opposite direction, we have to apply the force that notation. So this is how we're going to apply, which I have shown just below that fixed support diagram, which is reaction at that moment. You can apply the moment as well as the vertical, which is opposing to the vertical movement, and right as that horizontal force is basically used to denote the horizontal restriction movement. So we will. I'll wait a minute. I'll share my screen. So the another diagram. So there you can clearly see the difference between these kind of support, how it look like, and how can you identify with respect to their looks. This chart shows the notation of kind of support. First is roller support. Roller support can be denoted by this force symbol. First only has a single and second as double roller. You just stick with the roller. If you just given the roller in between that diagram, that is nothing but the roller support. And every symbol shows that it will restrict the 1 degree of freedom, and only one force which is perpendicular to that surface is going to apply on this kind of support. Now, second is the pin support. Pin support is nothing but hinge support. So in this condition, we are going to restrict the 2 degree of freedom. So this three notation is nothing but your hinge, and in this hinge condition, we are known that if you reduce the 2 degree of freedom, there must be two unknown forces going to apply. One is the vertical motion, and one is horizontal. You can take any direction. And now we move to the fixed support. And in fixed support, we have seen this kind of two notation. They might use any one of it. And if this kind of support you see in the diagram, you have to apply the three forces. Two is the one is the horizontal, second is first is the vertical, the second is the horizontal, and third is the momentum of that with respect to that support. And this is simple support which also gives the one vertical direction. So this kind of support you have seen. So we will basically go to our next topic is the beam. So we'll discuss about the beam. This kind of beam is basically divided into two subcategories. First, is statically determinants of beam, and second is statically indeterminate beam. So, what is exactly mean indeterminate and determinant? Uh, there are number of equation you required. It's like if you are two unknown, you need a two equation to solve that kind of that problem. So if three unknown will be there, then you need a three equation to solve that problem. In this kind of a beam condition, if you have sufficient force unknown is available, and you are able to find out with respect to the diagram itself and the static condition given. So with respect to that, if you are able to find out all uh, your unknown forces, that is not nothing but statically determinant beam. If you're not able to find out these kind of forces with given equation, or simply three equation, summation of the horizontal forces, summation of the vertical forces, and the moment. If you apply this kind of equation to this, and if you are able to find out the three whatever known you have, that shows it is statically determinant. If it is not, then it is statically indeterminate beam. So first we move with statically determinant beam. So in which first beam which is come as simply supported beam. Simply supported beam, as we know, and we will going to see in the other diagram. So no need to worry about it. Simply supported beam only has a two unknown, and the forces is vary with respect to different kind of load. It has a mini load structure is available. So it can be act a different kind of load, and another is overhanging support. Overhanging support is nothing but it will have a two support at the center, but the end portion of the beam will be in the air. So this kind of beam will called as overhanging beam, and this kind of beam, it might be in determinant or indeterminate, because it is based on the load is going to act on the different kind of forces we are going to apply on that beam. So it might be, or it might not. And third is the cantilever beam. So in the cantilever beam, we know that only it has the fixed support at the one end, and at another end is in the air. So just because of that, it always be determinant. And if you come to the statically indeterminate kind of beam, so in which the fixed beam which will come in the play, because in the fix which shows that the both end of that beam is going to be fixed. So if it is fixed, that shows that two moment is going to add into it, and force unknown forces will be added into it. So and definitely it is going to be a statically indeterminate kind of beam. Then afterward, the prop kind of cantilever, and prop also it's also simply supported cantilever we used to call, but it's prop cantilevers, and it's a simple kind of cantilever beam. Only thing is it has support at the free end. So in this condition, there will be one force is going to add, and another two forces we add in the fixed support. One rotation moment will be there, so it added for unknown. This because of that, and we only have three equations, so it is not possible to find out for unknown with three equation. So just because of it became statically indeterminate. And continuous beam. Beam is simply it has a long span, and it has a number of support in definite distance. So it is quite difficult to find out, because many forces going to add, and there are very few known support will be there. So just because of that, this kind of beam is going to be statically indeterminate. So we'll see there how it look like with this kind of beam. This is the chart I have with me, and first on this chart, the first diagram is for the cantilever beam. Second is the simply supported beam. Third is and a simply supported beam in the left hand side. It has a cantilever. It has a hinge support, and another is the roller support. And in overhanging beam, it has a two roller support in between. In continuous beam, as we seen at the one end, it has a one hinge and three roller support. A fixed beam, it has two both side fixed, and in the cantilever, and it's simply supported, but we used to call it as a proof beam. So these are the basic type of the beam, and the load I'm going to discuss. Yeah. This is the this In this way you can give the load, and this in this way we used to apply the unknown reaction on that beam. Uh, and the type of force is going to add on this beam is first load is point load, and another is the uniformly distributed. Third is uniformly varying, and another is the concentrated moment. And this kind of load we are going to see in detail when it is necessary, because most of you people are very well known about this. So no need to discuss more. I have taken few example which shows a different kind of forces going to act on the beam, and it is quite necessary to understand this. The first is first beam I have taken as a cantilever beam at some distance. It has a vertical link and one horizontal link, and at the end of that link we are applying 10 kilonewton of force, and the vertical link is the 1 meter, and the horizontal is 0.5 meter. Another from if you move from that load to the some another extent, so it has a vertical length 1 meter, then horizontal length 0.5 meter, and once again at the end of that 5 kilonewton of force is going to act in the downward direction. From that point, C point, if you move to the D point, at that point you have a clockwise 10 kilonewton of forces, and moment, and kilonewton meter as a moment, and vertical direction 10 kilonewton as a force. So the first force, as we know, when you apply at the end, it will create a moment, which is nothing but 10 into 1 meter. So the force will going to be 10 kilonewton meter, and it will be in the anti-clockwise direction, and it will be act at the B point. So and there also, because you are applying in the right leftward direction, the 10 kilonewton meter, which force is going to shift toward the beam. So that force is going to so just because of that single force, the moment is going to create in that point at that point, and once again that force 10 kilonewton meter transfer to that beam. And the fixed at a fixed state, we have taken the three unknown forces, that reaction at A in vertical direction, reaction at A in the horizontal direction, and the moment at A, which is we have taken as a in the anti-clockwise direction. So as we seen in the B point, the reaction. Now we go move to the C point. At C point, we have seen that 5 kilonewton force, which is act vertically downward, and the distance from the C point is zero point 0.5. So zero point 0.5 multiply apply by 5, which will become 2.5. The moment which is created at C point is 2.5 kilonewton meter, and it is in the anti-clockwise direction. And as we know that the force you are applying in the vertical direction, it also moves to the C point, because it vertically apply, and the opposite reaction in the vertical, that link which is attached to that beam, it push that rod in the downward direction. Just because of that, the 5 kilonewton force is going to act on that point. So here also just because of that eccentric force. The two unknown, two forces going to act at the C point. First is the rotation, and another is the point load. Now we move to the C point. The C point already the force is given and the moment is also given. You can find with respect to that. Now we move to the another example. In this example, I have taken that first is the hinge point, and another and it is supported with roller support. And if you move the hinge point from 1 meter, it has a vertical 1 meter link and a horizontal zero point 0.5 meter link. And at the end of that link, we apply 3 kilonewton of force. So with respect to that force, we directly move to the forces. At the hinge end, we will get two reaction. One is the horizontal reaction, and second is the vertical reaction. When you move at the first 1 meter away from this hinge point, where you find that you will get one moment, which is in the clockwise direction. 3 into multiply by 1, which is 1 meter away from the your beam, which is center of your beam. So 3 kilonewton meter, the torque is going to act at the that particular point, and the force which is acting from left to right is shifted toward the beam. So as you see in the just right side to that beam, and if you move 2 meter away from that hinge point, so you will find that two forces, which example shows the couple. Couple is nothing but the forces which has a different direction with the same magnitude, and which is separated by some distance. So here it's separated by 2 meter, and the force is going to act in the opposite direction. It's nothing but 2 kilonewton meter. So the magnitude is become of that couple is the distance into one force. So here 2 meter into 2 kilonewton, that became 4 kilonewton meter. Torque is going to act at that point. So there will be no force is going to develop because it is couple, and it only create a rotational moment over there. And now the if you move the 3 Newton meter from the hinge support, so here you have a see this link, 1 meter link, vertical link, and zero point 0.5 meter horizontal link, and one at the end of horizontal link, you can see the 2 kilonewton of meter force is going to act in the vertical direction. So what will happen here, the one torque is going to be generate in this at that point, and the force at 2 kilonewton meter, which is shift to the joint point of that beam and the vertical line. So here the force is 2 kilonewton, which will become, just because of that, it will create a moment, and the magnitude of that moment is 1 kilonewton meter. So this is how you can find out the different moment. These are the basic moment which is very important to understand, and just because of I have taken this kind of example. Now we move to the load, and the basic type of load, we have seen that the uniform point load, uniformly varying load, uniform load, and also these are the quite different kind of load. It is with respect to varying with respect to time kind of load, and if the load is varying with respect to time, it's called a dynamic load. And if the load of that beam is not going to vary with respect to time, it's called as a static load. We are going to move one by one. First is the static load. In this static load, first is the dead load, and second is a gradually applied load. So first, what is dead load? Dead load is nothing but once you apply the load on that link, it will be always remain same over there. So it is not going to move, and it is not vary with respect to time. It's like uh, if you apply, you have seen many, because once any structure is going to form, and if you apply the load on that structure, it will be same throughout its lifespan. So this kind of load is going to be used to call as the dead load, and gradually applied load. It's nothing but with respect to time, we are going to add that load into that beam. So it will be gradually, with respect to time, is going to increase or decrease. It depends. Now we move to the dynamic load. So in dynamic load, it's dynamic word is nothing but it's vary with respect to time. And the first is the impact load. As we know that impact is something, but suddenly the hammer reaction, when you hammers on something, so it is nothing but the impact load. Suddenly you get something. It's also called as the shock load and suddenly applied load. So this kind of load, it is for the short time of wait, but the magnitude is quite high. Also, it's called as fatigue load, and fatigue is nothing but fatigue variable load, a cyclic load, and fatigue and cyclic load is such kind of load which is repeat equal after equal time. It's like you know the cam and follower kind of mechanism. At a certain each and uh, every rotation of that cam, follower has to follow, and that follower, if you're rising the follower, it goes to some kind of fatigue. So it your cam is applying some force on that follower. So this kind of load you used to call as the fatigue and cyclic load. uh, and I have taken for a few this kind of to this is another point is axial load. When you apply axial load on the any kind of beam, it is going to be perpendicular to the cross section of that plane. And if the shear force is taking place or tangential forces is acting on that plane, which will be always parallel to that cross section. And when the shear force is going to be act, shear forces act in the two way. First, it is passing through the center of transfer load, which we used to call as transfer load, which is passing through the center of that cross section. And another is the eccentric load, which is not passing you through the center of that cross section. Nothing but it is parallel to the cross section, but it will be away from the cross section. It act away from the center of that section. So here are the three diagram I have denoted with the pressure with respect to time. Here the static load, you can see the diagram which pressure remains constant throughout the time span. Second diagram is about gradually applied load, in which we applying the gradual load and at up to certain time span, and after that the load will be constant. So this is how the gradual load we are going to apply. With respect to time, it is increasing, but after some time, it will be constant throughout its span. But if you come to the impact load, the time span of applying this load is very small, but the pressure, the magnitude of applying force is very huge, and just because of that, it is very dangerous in this condition. And on this phenomenon, the gate has a very interesting topic, which they used to, and most of time they used to ask at least one question on this topic, which is impact load. So in this impact load, they actually combine with a different kind of chapter, like strain energy kind of chapter. So in which they used to combine this kind of chapter, and they used to ask combined question. So we show that impact load. We know the impact load has a small time span, and due to that, the impact is going to add, and it will create a sudden reaction. Due to that, the work is done on the forces. Due to that, the deformation is going to take place. So in that condition, we have to find out the deformation due to this impact load. Before that, going to that impact load mostly you can see in the IC connecting rod, which is suffer in a huge impact, because once in the specifically expansion stroke. Uh, Then also the spur gear, each and every teeth of the spur gear, because it is always come in the contact, and it apply the impact stresses on each other. To find out that, we have to find out the impact factor. Impact factor is nothing we are going to add, which is if we multiply to the static load, we will get the dynamic load. So impact factor, which formula is 1 plus under root 1 plus 2h divided by change in length, or change in dimension of that structure. So h is nothing but the height from the when if you drop something, it's like hammer. If you take an example of a hammer, hammer is you're hammering on the iron block. From the distance, you are hammering that iron rod. That is nothing but your h value, and the deformation is going to take place in that iron block. That is nothing but your change in length. So in free fall condition, we are very well known that formula V is equal to under root 2g h. So same formula we are going to use to find out the value of h. H is nothing but v square of 2g. With respect to that, you can find out. And second, you should keep in mind that impact factor value will always be greater than equal to 2. How it is? Because in sudden and instantaneous applied load, if it is sudden, very instant load, it's like if you keep these two hand in a closed pan, and if you apply jerk from one hand to another hand, there will be no the height difference, because the height will be zero, but you get some kind of force. So in this condition, the h value becomes zero, and if impact factor will become 2. So in this condition, if you want to find out the sudden load, so which is nothing but 2 into multiplication of static load. Similarly, if you want to find out the sudden deformation in the sudden reaction, equal to twice of the the deformation in the static condition. In the static condition is something but PL by AE, and P is your nothing but sudden load. Similarly, if you move to the dynamic condition, in the dynamic condition, you have to find out the impact factor. And with respect to impact factor, because it depend on the different kind of situation, different the height, based on the height. If height varies, the impact factor is going to vary. And with respect to that, the dynamic load also varies, and the dynamic deformation is also going to vary. And if you want to find out the impact stresses, in which the dynamic stresses, which is nothing but the impact dynamic load divided by area of cross section. So how this stress is going to be reduced? If you place the value of change in length there, so it will become it which shows impact factor is directly proportional to A. If you reduce the E value, which is modulus of elasticity, it will reduce the impact dynamic stresses. And also will reduce once you increase the length of that rod, and the area of cross section of that rod. So this is how you can find out. And these are the some basic example with respect to that formula. So on the basis of that, you can find out the exact impact, and exact value for that. So first example is sudden jam. When This example is about the crane. If crane is at the moment it releasing the load in vertically downward direction, but if suddenly you stop, it will give some sort of jerk, because that mass, whichever you're going to lower, it has some moment. It's kinetic energy, and also has the potential energy, which is going to stop. So it give a jerk, and so it is suddenly apply the stasis on that wire. So we have to find out the stasis, because if you know the stasis, if you give suddenly jerk, so for the safety purpose, we should know the sudden stasis should be the capability of that wire should be higher than the instantaneous load. So this can be calculated with respect to that kinetic energy of that mass equal to the strain energy which is stored by that wire. And this formula we can find out with respect to the we will see in the detail in the strain energy formula chapter. So we were there we will see how this formula will derive from the different notation. So basically it is stress square equal to volume divided by twice E. So from there you can find out the instantaneous, because mass is mass you known for this mass, and velocity of that mass is also known, area of that wire is known, length of that wire is known, and also the modulus of velocity of that wire known. So only unknown value is the instantaneous load, instantaneous stasis. And with respect to instantaneous stasis, once you find, you can find out the instantaneous change in length of that wire, because stays PL by A, and P divided by A is nothing but stays. If you know the stays value, you know the length, and you know the E value, so you can find out the instantaneous length. Now we move to the second example. Here we are moving the mass with respect to two wires, and it is very equally distributed that weight of that wire, and it has some velocity v and weight w. So in this condition, same formula is applicable. It has some kinetic velocity, and once you stop that movement, it will give some kind of jerks, and the entire energy is going to be equal to the total strain energy is added into that wire. So if you the mass and the force is going to be applied in this condition, and the mass is going to add, and the half of the wire is W by 2, and divided by G, which shows the half weight is sustained by the one wire, and the half weight is sustained by another wire. So we have to calculate for the half wire first. So this is how you can find out the stress value, and with respect to the stress, you can find out the instantaneous change in length of that wire. The another example is about the hammer. So once you see the hammer is on the iron block, it has some length. Once you hammer at certain height, so it will deform at length delta L, and it has some potential energy. So a hammer has a mass em, and once it release from that height, so what will it will reach at the surface of your iron, and once it still move the deformation. So the total displacement of that hammer is going to be h, which is height from the mass to the surface of that iron block, and once again total deformation of that iron block, which is del. So total displacement is h plus del. So total work done is going to be pressure into the force into height. So this is how you can find out, and this entire force is going to be equal to the strain energy, because once you apply the potential energy of that and kinetical and potential energy of that, in this condition only we have taken as a potential energy. The potential energy is going to be used to deform that iron block. So iron block is getting deformed, and that deformation thing is going to add into strain energy. So with respect to that, also once again you can find out the value for stays and deformation or total instantaneous strain in that section. So this is how we cover this impact stresses. In the second, in the upcoming section, we are going in the upcoming lecture, we are going to see the different cross section, and different how these forces and are going to act on it, and how many forces will be available. So for today's lecture, we will be stop here.